Thank you. For kind of our societal impacts related to AI. And it seems like for the past several years anyway, every time I would find a paper by Deborah, Raji, and that paper, written years in advance before it like became a public issue, clearly articulated the issues, provided frameworks for audits and accountability. So I learned to go right to the source and start like reading the papers when they would come out. And it's had a profound impact on my thinking. And I'm so happy to have been able to bring her here for the colloquium. Deborah Raji is an academic fellow at the Leadership Conference on Civil and Human Rights, formerly Senior Trustworthy AI Fellow at Mozilla Foundation. She's on a whole bunch of advisory boards, Center for Democracy and Technology, AI Governance Lab, Health AI Partnership, Teach AI, Real ML, Center for Civil Rights and Technology. She also has a bunch of awards, the Forbes 30 Under 30, Tech Review 35 Under 35, Time 100 Most Influential in AI, recipient of the 2024 Tech for Humanity Prize, 2024 Mozilla Rise 25 Award, co-recipient of the EFF Pioneer Award. She consistently speaks truth to power. And so I think you'll all really enjoy the talk.
Can everybody hear me, or is this on? Okay, great. Okay, yeah, thanks, Deb, for that introduction. That was like a list of everything I've ever achieved in my life. So yeah, I'm Deb. I recently just finished like a long, I was with the Mozilla, a lot of this work I was able to do because of the generosity of the Mozilla Foundation. I was a Senior Trustworthy AI Fellow for many, many years. I'm also doing a PhD in computer science at Berkeley. And I'm currently working a lot with the Leadership Conference. So for those that don't know what the Leadership Conference is, it's sort of like an umbrella organization that coordinates a lot of civil society groups within the US. So like NAACP's LDF, ACLU is part of the Leadership Conference, a lot of immigrant rights groups, that kind of thing. So been helping them think about these topics recently. So that's sort of like who pays my bills. And so today I wanted to talk about sort of how we're thinking about audits and accountability in this sort of AI world. So first I have a little quiz I like to start with. Does anyone recognize this person? No? He's not someone you personally know? Okay, so this is Robert Williams. He came home from work one day and was arrested in his front lawn on his birthday in front of his two young daughters. And he was completely confused when he went back to the police department. He found out that he had actually been incorrectly arrested because of a false facial recognition match. Does anyone recognize her? Okay, I think we might be in like different social media news circles. But this is also an old story. This is a 2016 story of Tammy Dobbs. She's a woman in Arkansas that has cerebral palsy. And when Arkansas switched, so Arkansas used to have a situation where Medicaid, Medicare benefits, home care benefits, were mediated by human assessors. And in 2016, 2017, they switched over to an algorithmic system. And the number of care-assisted hours that Tammy Dobbs received went from about 52 hours a week to 32 hours a week, drastically impacting her quality of life. This is a more recent example. Does anyone recognize these guys? This is a California specific one. So these are the California nurses that recently went on strike last May. The National Nurses Union and the California nurses went on strike because they were being forced to use generative AI tools as part of their mandate for care. And so they felt like it jeopardized patient safety, reduced the quality of their work to have to use these tools. So they went to the streets on May to demand that they had agency as workers in terms of how these models were used and deployed. So these are all examples of different individuals and groups that have been sort of negatively impacted by the deployment of these systems. Do you recognize her? I don't know. So you should recognize her. This is me. And so to just sort of describe like my role in this space, I'm going to describe a very weird experience I had, which was this is, the olden years of like Biden administration. At the time, Senate Majority Leader Chuck Schumer was hosting an inaugural sort of AI Insight Forum, bringing together a bunch of leaders to talk about AI policy for the Senate. And so I was really fortunate to be there, and I was just kind of like having a ball being there. And then, someone was like, "Oh, like, do you know who else is coming?" And I was like, "Oh no, I have no idea." And literally, like the day before, they like published a list of participants. Oh, and it looked like this. By the way, this is me. My friend saw it and she's like, "You're the only one that's not a CEO." And I was like, "Thank you for noticing that." Yeah, so you can see it's sort of like a crazy place to be. And I think a lot of the questions I got after this was like, why are you there? Like, what are you what are you doing in this room? And so I think explaining why I'm in this room does a good job of explaining what my research is about and sort of how I enter the space. So this was a closed door meeting, and so a lot of people don't actually know what was said. But I can tell you the kind of download what happened, which is people saying that AI will take over the world. So, like Bill Gates talking about how AI is going to transform everything on the education front. Sam Altman and the folks from OpenAI talking about like sort of worker productivity boom and sort of reiterating points that they make in the press around that. Again, sort of discussing sort of the beginning of this AI age that's like just at the cusp. So there's a lot of this like positive sort of superhuman good that people imagined was going to happen because of AI. And then in the same room with some of these CEOs was the exact same narrative, but from this sort of like doomerism perspective of like Elon Musk talking about the double-edged sword and dual use. Eric Schmidt and some others have written already about, the great risks and dangers of AI. Sort of losing control of this technology. And then Sam Altman somehow being able to play both sides and also talk about, the risk of extinction and things like that. I was just talking to folks today about how sort of these boosters and those that have this great hope for AI and those that are critical, like massively critical, are sort of two sides of the same coin, where they both are incredibly optimistic about what the technology is and what the technology can do. They think the technology is going to be so powerful, we're going to lose control of it, or it's going to be so powerful, it's going to solve every problem we have. And I'm sort of like the lone, like this is my perspective and what I bring to the conversation, which is that, at the end of the day, a lot of the harms that I described at the beginning of this presentation, a lot of the humans that I interact with through my work with civil society, is because the systems just didn't work. Like, it was a false facial recognition match that put Robert Williams in jail. It was an incorrect assessment that reduced Tammy Dobbs' quality of life. And those nurses are protesting because they had concerns around the performance of these models. And so, we're seeing more and more headlines. It's becoming more and more of a publicly visible thing. But a lot of these systems actually really fail to perform in the real world. And a lot of the harms from a product safety perspective that we're experiencing, especially for marginalized groups, is because of these failures. There are different types of failures, but nonetheless, it's because a lot of these systems kind of stumble to perform in reality, and they kind of fall short of our expectations of them. So that's sort of, what I do is that's why I'm in the room. I was sort of the fact checker of the room, where every time someone said something crazy, I was able to be like, actually, actually, it's not quite as performant as you think it is, whether for good or for bad.
I was just going to suggest, can we
close the guy?
Pull it off?
Let me see. Oh, I didn't even notice it was up there. Let me see. Do you mind click? Do you know what to click? Under more?
Let's see.
Okay.
Is there a cursor? I can't find it.
I can't see it, yeah.
Difficult. Oh,
I mean, yeah. Okay. No, it's fine. The aesthetic is off, but that's okay. But I was just going to explain sort of like, I was sort of the way that I saw my role in this room and in a lot of the rooms that I end up in with much less fancy people, is sort of asking this question of what does it mean for AI systems to work? And when these systems fail, sort of how do we hold different stakeholders accountable? And so I'm very fortunate. I've sort of been in this space, kind of Jed alluded to it. I've been thinking about these problems for like maybe too long. And I've been able to work with different practitioner groups. So the Health AI Partnership, Teach AI, Gov AI, who all deal with AI deployments in different industries. I've been able to work with different civil society groups. So like the ACLU, the Leadership Conference, the Center for Democracy and Tech, as AI Governance Lab. And then I've also been able to work with different governments. So as different governments were trying to deploy AI systems, I've been able to work with folks in Canada, the US and the UK, and then different agencies. So mainly FTC, like National Institute of Standards and Technology, and ONC, which is sort of like a regulator of like information technology. But throughout all of this, like I've just gotten very well versed in playing that bad guy role of pointing out all the ways these systems might fall short of our expectations, but more importantly, trying to connect those failures to expectations we might have in terms of accountability for those that facilitate or enable these failures. So, ambitious schedule for today will be the following, which is I'm going to share sort of two views that people have in the policy space about AI. Some people view AI as a product. Others view AI as an organizational policy change, and I'm going to just talk through both of those. And then I want to talk about AI functionality. What does it actually mean for these systems to fail? And then AI accountability, sort of when they fail in ways that hurt people, who do we hold accountable and how? So first, just so we're all on the same page, what is AI? I think when I put the slide up, people will say like the model, the algorithm, the data. Like we all know that these are components of what a quote unquote AI system involves. But the data is sort of derivative of a lot of surveillance infrastructure, digital surveillance and also physical surveillance infrastructure. There's all these like data supply centers and supply chains, energy consumption, data annotation infrastructure, state-of-the-art algorithms, research culture, compute applications, the market regulation, the regulatory setting, organizational settings, the product, the human users, downstream impact. So all of these things are like part of the conversation of how AI is defined. And so for those of us in this space, I think the language that people try to use is that, okay, like AI is not just like the technological pieces of Lego that stick together. It's like everything around it that contributes to the definition of how it impacts people's lives, is open to examination, is open to investigation. So we call this a socio-technical system. For those that aren't as familiar with it, I'll just give a very brief definition of what this is. There's a group called Data and Society in New York City. It's a group of sort of social science researchers that think a lot about technology, and they've been thinking a lot about AI as a socio-technical system. They've also been engaged in a lot of policy advocacy work, and so they published a report about a socio-technical perspective on AI policy. And I think they have a definition I really like, which talks about how like a socio-technical system is not just about how technological design choices impact social outcomes or social outcomes impact the technology, but it's really about the interaction of both of those things. So it's neither one or the other, it's about the kind of connection. So the example that they give is that of the bicycle, where I don't know if people are really familiar with the history of the bicycle, but they used to have these huge front wheels and used to be these sort of like very dangerous devices, transportation devices. And you can kind of see an example of it there. And it was used by sort of these like macho men to like race each other. Like part of the appeal of the bicycle was its danger. But yeah, it's very dangerous. And when you see the evolution of the engineering design of the bicycle, it was sort of this interaction between society and technology, where the technology evolved in order to make the vehicle safer. And that was partially in response to a wider group of people wanting to engage with the bicycle and use it as a form of transportation. But also those people were like more eager to adopt the bicycle because of its new design. And so there's sort of this symbiotic interaction between the sort of technical design choices of the bicycle, and the way that society was interacting and engaging with it. And so this is the perspective that I think we take to a lot of how we view AI systems versus just, the technological component, but the whole system. And then also it informs how we see evaluation more holistically as well. So the first view I wanted to share was that of AI machine learning as a product. So, the question I get asked all the time is like, what does it mean for machine learning to work? What does it mean for an AI system to work? Something like ChatGPT, what does that mean? And I think a lot of people are overthinking it. It's like the kind of policy equivalent question would be like, what does it mean for a toaster to work? And I hope people in the room can answer that. In the same way, we know that a toaster that works, heats up the bread and doesn't burn it. We can kind of poke at the buttons of the toaster and it doesn't blow up. These are sort of standard product safety expectations we have of any device that we use. And I have a colleague that talks about like, AI is no exception to the existing sort of consumer protection laws that we would expect of any engineered artifact. So I don't have time to really go into this, but there's like a lot of legal requirements attached to making a toaster work. A lot of market compliance requirements, procurement requirements, advertising rules, product liability and tort rules, and warranties. So that's pretty much a guarantee of the toaster working for a particular period of time. But all of these things also apply to AI systems. AI products are not necessarily different. At least that's what the argument of view one is. And so there's a lot of things that we can learn from other fields about how to think about product safety. There was a time in which it was incredibly dangerous to get into a car because manufacturers were not careful about how to safely build those cars. And Ralph Nader in the 60s, all the way through to the 80s, actually, and it's still going probably, was really pushing on these manufacturers to think through putting cars on the market that actually met certain safety criteria. And so we've had this whole era of consumer protection guidance informed by a lot of the advocacy on vehicle safety. Another sort of maybe sadder example is food safety and pharmaceuticals, where people were literally selling snake oil in order to heal people from various diseases. There used to have literal poison in food, and I guess what's his name? JFK, RFK would probably argue that there's still poison in food, but we've evolved the FTC in order to address some of these issues. Like the creation of the agency is the direct result of a lot of on-the-ground advocacy from folks that did very proactive testing to see whether or not these products that were put on the market were safe. So that's one view of how to see AI in policy. Another view that I'm just going to mention briefly is this view of AI and machine learning as like a policy intervention. So the way this view goes is that we have different organizations that make decisions about an impacted population. We have hospitals, we have schools, government. Each of these institutions have certain policies that mediate the way that decision makers and stakeholders within that institution affect an impacted population. So, there's a policy at the hospital that informs how a health worker behaves with patients. And sort of the AI as a policy intervention view is to say that at the institutional user level, they're changing the way that the user interacts with the patient by changing the sort of guidance or the policy that's informing the user decision-making. So, how well does the AI system sort of change the behavior, whether it's direct decisions or other indirect decisions of these different stakeholders within these organizations that then affect this impacted population? So that's a very dominant view in policy as well. And then the kind of relevant implications of this is, I don't know if people have read Moneyball. I'm getting weak nods. Brad Pitt was in it once upon a time. But the story of Moneyball is a coach that effectively uses statistical methods in order to better understand, baseball dynamics and then pick the best players for his team. In the Obama era, there was this idea of having a similar kind of like statistical based approach for government policymaking. So they had this method or this slogan of we choose the policies that work. And so they literally, like, these are a bunch of Obama era bureaucrats pretty much. And they wrote this book called Moneyball for Government, where they talk about, if we want to enact a particular policy within government, we want to have statistical evidence for it. So that particular attitude, there's a cohort of folks in the AI policy space that when they see AI as a policy change, they also see sort of the need to collect statistical evidence for, why should we use AI versus stick with the status quo. So that's just sort of a presentation of the two views. How does that affect how we think about when these AI systems fail? So, what does it really mean for these models to work? One is just like a very simple definition. This is like encyclopedia definition of evaluation, but sometimes it's helpful for people to understand this. When we talk about evaluation, we're saying that we have really clear articulated expectations of what we want the model to do, and then we have reality, and we're trying to quantify the difference between what we want the model to do or wanted the model to do and the reality of what it actually does. And so the challenge with machine learning evaluation and AI evaluation in particular is that we don't just use it for like algorithm selection and competitive testing for like research purposes, which is, I think, how a lot of people see the value of evaluation is like, oh, I just want to pick the best algorithm, and so I want to evaluate that algorithm, and that's why I'm doing the evaluation. But as things start, as these models start making their way into products, it starts getting incorporated into product safety testing, statistical evidence and litigation, procurement processes, pre-deployment testing. I could just go on, but effectively, it's a very loaded process. So whatever your assessment of the model is actually feeds into all these other things that folks are going to do with that assessment. And I don't know if I have time to really go into this, but me and my advisor, Ben Recht, we taught a class on machine learning evaluation last spring. And he was very offended by this slide because it starts at 1980. But like as part of that class, we went through sort of machine learning evaluation practices. And I just wanted to show you a little bit. Yeah, he was like not happy. He was like, I was alive. And I was like, oh yeah, sorry. But it's the antiquity era. It's sort of like the pre-1990s. I don't know. I'm sorry if I'm offending anyone. But like there's sort of the early machine learning evaluation era. This is sort of like at the, one of the first ICML proceedings was like, mid to late 1980s, when people were deciding that machine learning was going to become a more statistical practice. People started developing some high-level benchmarks. I think the most popular from that time is the UCI machine learning repository, which is a small set of it's a repository of different, small benchmarks, small data benchmarks. And then there's sort of the Middle Ages, which is the 1990s to 2019.
Instead of meeting, like, then you should.
Oh, hello. I think there's some. Oh, okay, that's fine. So there's sort of this Middle Ages of machine learning evaluation benchmarks, which is sort of like when ImageNet, which is a big computer vision data set, became popular, the Netflix Prize, which really advanced a lot of the work in recommendation systems, and then Glue and Superglue, which were sort of pivotal anchor points for NLP development. And then the sort of modern era, which is 2020 onwards. And we have like a whack ton of benchmarks. Folks that work on machine learning probably recognize a few of them. GSM-AK is a bunch of math problems. Human eval is meant to be sort of a simulation of human preference data. Chatbot Arena is like an actual kind of interaction zone for real user feedback on model performances. But you can kind of see there's a lot more diversity in this sort of modern era. And MMLU is a bunch of multiple choice questions. And then sort of parallel to this benchmark evolution is a bunch of evolution on the game front. So the role of games as benchmarks has also been a huge part of the history of machine learning evaluation. But one thing that we kind of pulled out pretty early on in the class is that there's sort of a consistent set of assumptions behind especially the practice of benchmarking in machine learning evaluation. And notably, one of the things that we taught about was this idea of the holdout method. So the holdout method is kind of like the statistical argument for why we use benchmarks. But unfortunately, it's sort of holding on to a lot of assumptions about how we collect data and how we set up these benchmarks. So the holdout method sort of has a few key assumptions. I'll just name them. So one of them is that we have a real world population and we're pulling a sample from that population. There's an assumption of like an unbiased data sample, that the sample that we take from the population is sort of representative of that population. There's also this assumption that, when we take this sample from the population, we split that sample into a training set and a test set, and the training set and the test set come from the same distribution. Oh, yeah, sorry, that was too much math, but okay, I might show it anyway, sorry. But pretty much there's another set of assumptions around, well, when we take this test set from the training set, we're first picking candidate models from the training set, and we pick our kind of ideal model, best model, and we evaluate it on this held out test set. And so the training set cannot overlap with the test set. So this is called the iron vault assumption, which is that the test set is completely separate from the training set. Oops, sorry. And then the sort of final thing here, the sort of final assumption here is that this test set, this is like a little bit of a trickier assumption to hold on to, but the TLDR of this is that not only do you have this training set and this test set, and you've held out this test set and kept it in an iron vault where you don't see the test set during model training, but that test set is actually representative or indicative or meant to be indicative of the general performance of this model. So the test set is actually supposed to represent something. The test error is supposed to represent something about the population error. And there's a bunch of like mathematical justifications for this. And so like the fun way of describing this with like no equations is a paper that we wrote based off of a children's book called Grover and the Everything in the Whole Wide World Museum. And we were sort of critiquing the way in which these assumptions failed for modern benchmark practices in the machine learning community. So there's this book, it's called Grover and the Everything in the Whole Wide World Museum, and it's about a Muppet called Grover. And he is going to a museum that claims to have everything in the whole wide world. And he's very excited because he's going to see everything in the whole wide world. And so he goes, the book is just him going from room to room. So he goes into the carrot room, for example, and sees a single carrot. He goes into something called the tall hall, and it's a bunch of tall items. You can kind of get the gist of it. It's like arbitrary rooms with arbitrary combinations of items. And then at the end of the whole adventure into this museum, he's like, okay, I've seen a lot of things, but have I seen everything in the whole wide world? Where's everything else? And there's a door that leads to everything else. And it like leads him, it's the door to the outside world, where he's like, oh, yay, everything is outside the museum. And we use this story as a sort of critique of the way in which people don't address the assumptions behind benchmarking when they design them in the machine learning community. So in machine learning, people in the Middle Ages became very interested in having models that had this notion of general performance. And so they started building benchmarks like ImageNet and Glue that were meant to be indicative of performance in a general sense, in an underspecified sense. And so, ImageNet claims to be an attempt to map the entire world of objects. Glue is literally called the general language understanding evaluation. And one of the things we point out in this paper is that benchmarking, data benchmarking, is inherently sort of contextualized and specified. Like you can't encompass everything in the whole wide world with these benchmarks. So, in the case of ImageNet, there's task bias, where 118 of the classes are dog breeds out of the 1,000 categories of the ImageNet data set. And glue, this was actually really hard to figure out, but glue is a set of, and I'll talk about this later, a set of very specific tasks that it's like 6 to 8 tasks, not even that many tasks, that were deemed to be of importance to the machine learning community. They talk about in the paper, we disseminated a public call for task proposals, and then they use a bunch of logistical heuristics to filter through. So not anything more methodological than just like, will this data set upload and things like that. And we talked to the authors of Glue and we were like, what is this public call? And they were like, oh, it was a Twitter survey. And we just people suggested data sets that we thought were interesting and we just uploaded it. But again, they're claiming that to be an indication of general language understanding evaluation. So, what happens when people are claiming that their model, their benchmark indicates performance in this general way, but it doesn't actually, you end up with this issue of benchmark bias. So one very clear example of this is, a lot of the mainstream vision benchmarks, if you look for images associated with the word wedding, you see sort of the Western representation of that concept of wedding. If you were to translate the search term to derive the images for wedding, you would see a very different set of images. So these authors translated wedding into Hindi and then looked for images of wedding in Hindi, and it's a very different set of images. So if you were to recreate ImageNet, but just translating the terms into another language, you would have a very different ImageNet. And so obviously it's not encompassing of the full scope or a general representation of the images. This happens with object recognition as well, even for objects that you don't expect. So, soap looks very different in the developing world versus our representation of soap in the developed world. And what these authors did was they kind of looked through where a lot of these images were coming from, and they're kind of disproportionately coming from the UK and the US, unsurprisingly. And then, what becomes tricky is when benchmark bias actually translates to evaluation protocol for products that are actually going to end up in use. So facial recognition, this was starting in 2016, 2017, became a major application area for the computer vision community. People were very eager to use it in immigration, in law enforcement, for human identification. And a lot of these are the major facial recognition benchmarks from that time. And you'll notice that this pilot parliaments benchmark, PPB, is the only one that's really balanced in terms of gender representation of subjects and sort of darker and lighter skin representation of subjects. And so that's because we created that benchmark specifically to have this property. And so there's benchmark bias issue also manifested in the benchmarks that were being used for facial recognition at the time. And what that led to was sort of this evaluation of commercial facial recognition products that were being pitched to, police departments, to immigration. And when we evaluated it along the different demographic axes, we found that the models, because they were sort of evaluated on a different type of benchmark, had kind of missed the fact that they were drastically underperforming for this darker female subgroup than the other subgroups. And again, because this is not just for paper publication purposes, this is a benchmark that led to products that were being deployed or pitched for deployment. The National Institute of Standards and Technology had to actually step in, and they created, as part of their facial recognition vendors test, a demographics test to look into how well these models performed along different demographic axes. And so one of the kind of early wins for this work was that NIST, which has way more capacity than we do and evaluated way more models than we do, found that in many cases, minorities were, up to 100 times more likely to be misidentified than white subjects, which was really scary because these are all products that were, being pitched for use by government, law enforcement, and immigration. So the fact that it was so much less functional for these minority groups was very alarming. I'll also say another kind of aside on the benchmarking front. I know I should move on. But I think sometimes people really underestimate that even the most basic assumptions of the holdout method are violated. So benchmark bias is probably the one that people like to talk the most about. Data contamination is another one where, data from the test set finds its way into the training set. I think one that people don't even recognize is the fact that the training data set and the test data set are coming from the same sample is a key assumption of the holdout method. And since like sort of the large language model era, we've had this issue where effectively, glue and super glue do have training sets, but there's this norm where people will train a large language model on whatever data set that they want. And then they'll fine tune it on the training set for glue or super glue. And then they'll evaluate it on this held out test set. And what that means is obviously their training set is whatever they trained it on, in addition to the training set for glue or the training set for super glue. And it's not guaranteed to be from the same distribution as the test set. And there's a lot of sort of consequences of the fact that this type of statistical assumption is violated, especially in the NLP space. So it's always been sort of like an unspoken way in which the holdout method does not apply to like large language model evaluation. I was also going to mention very briefly something else that was fascinating from this whole discussion was just the way the culture of evaluation has shifted for large language models. So, GPT-2 came out in 2019. It was like Alec Redford's kind of like pet project. It was put up on archive. It wasn't published or submitted to any conference. And the kind of evaluation is like very weird for the times. So a lot of it is very, it's like a little hard to see these, but a lot of these are very sort of like, just fun, pragmatic tasks that he was clearly just curious about. So he's kind of like, oh, can this model do translation? Oh, okay, it's not bad at translation. Can it do math? Okay, it's not bad at math. Is it good at reading comprehension? Cool. And so he didn't use any of the standard benchmarks of the time, which was glue and super glue for GPT-2. That technical report is just full of a lot of like ad hoc experiments around practical tasks. And you can see it's just very demo based of just curiosity about what the model can actually pragmatically achieve. And then by like GPT-3, which is the next year, OpenAI submits this model to NeurIPS, and NeurIPS actually has some criteria around evaluation. And so, they now start evaluating on sort of the standard NLP benchmarks, which are much more focused on linguistic competence. So like natural language inference and negation, and some of these kind of like more foundational linguistic competence tasks rather than the kind of pragmatic application tasks. And then finally, we end up with like GPT-4 a couple years later. And it's just like things that are more geared towards marketing. So like performance on the SAT, performance on the AP exams, performance on the MCAT. And so that's sort of interesting to see just the culture of evaluation shifting in this new era. So something else that's kind of interesting as well about the construct validity challenges is the way that these benchmarks play out versus how people really use these models. I don't think I have enough time to go into detail, but another example is a really common benchmark used for search engines is called simple QA. And so the way that we use like a Google search engine is that we write like a single word or a couple words or a sentence to capture what we want to search for. We very rarely write a paragraph into the Google search bar. And then we get like a kind of fixed response. And so the benchmark is really geared towards that. And so OpenAI kind of just like took that and then used that as the benchmark for the search capabilities of their ChatGPT products. And it made a lot of sense at the time. But at Berkeley, we started looking at interactions in Chatbot Arena for search and search-specific LLMs, but also general models like ChatGPT. And we found that people are kind of like insane in terms of how they interact with these search large language models. Like, it's really hard to read this, but it's like, this is like a search query where he asks a question, and then there's like a numbered list of like sub-questions and context. And so the kind of queries that people send these search LLMs is very categorically different from these one-liner search queries that people are asking, traditional search engines. So like understanding the way in which, and this is the benchmark that's published by OpenAI, right? So understanding the ways in which people actually use these models and how that differs from this sort of hypothetical use case or these anchored use cases will probably reveal some failures. The last example I was going to give, if I have time, is from the medical world. So this is from Google and some other folks. But MedQA is a very popular benchmark in the sort of medical LLM world, and it's based off of medical exams. The main thing you need to know is that there's a question, there's context to the question, and then the answers are in the form of multiple choice answers. And that's just to make it as easy as possible to evaluate the system. But in reality, when and I kind of learned this the hard way by interacting with actual people at hospitals, when a health worker is deciding to use something like ChatGPT, it does not take anything close to the format of a medical question answer of the MedQA data set. There's no multiple choice question involved here. They usually interface with the model through like an electronic health record platform like Epic. And the context that's given is like formatted very, very differently from the way these medical exam questions are formatted. So here's an example of the type of context that's provided through Epic for a particular patient. It's either a one-line summary or it's like a kind of rich set of doctor's notes. And this is sort of what they have as the context that they can feed into their questions, their sort of queries into a large language model. And these are just sort of like preliminary results, but you can kind of already see that a lot of the model responses are sort of disproportionately inappropriate, and particularly inappropriate for patient descriptions regarding Black patients over sort of the baseline population of patients. I don't think I have time to get into this, but I think the last thing I'll say about this, and then I have to probably skip through a couple of slides, but one interesting point, or one thing that I'm also exploring, is the fact that benchmarks, retrospective benchmarks in particular, are just one form of evaluation or one way to think about things that's very anchored to the history of how we've been thinking about things in the machine learning field for a long time. If we care about evaluations that are kind of connected to real world deployed systems, we have to sort of expand our definition of how we evaluate the model. But we also have to start thinking about, how do we evaluate the way users interact with the model and decisions or actions are taken in response to the model? How do we evaluate the way that this affects organizational outcomes and integration? And then how do we evaluate sort of the like societal level impacts of these systems? So if we want to shift beyond sort of a model-centric view into recognizing that we have evaluation goals beyond, just model performance and algorithmic selection, but all these other kind of accountability relevant goals, we have to sort of expand the scope of how we're seeing these systems. Okay, I have 15 minutes left, so I'm going to skip a couple things. But all this to say is that there's definitely a community of people that are thinking about how to see these models beyond benchmarks. But I just want to make sure that I have time to address the second part of this, which is the AI accountability piece, which is, why do we care about AI functionality, benchmarking or going beyond benchmarks? It's because we want to evaluate the system to feed it into a process of accountability so that we know when the system fails and we can kind of hold to account any stakeholder that contributed to that failure or the harms that fell out of that failure. So when someone gets hurt because of an AI system failure, sort of who's held accountable and why? So I really like this definition of accountability. This is by Bobbins from like 2007. But there's like a good survey by Waranga in 2019 on AI accountability that uses this definition very well. But the TLDR of it is that accountability is a situation in which you have someone making decisions. Those decisions affect, that's the actor. Those decisions affect an impacted population, the forum. And you have accountability when those that are impacted by the decisions of the actor have the information to make a judgment about the quality of the decisions being made about them. And, you know, the key piece of it is that their judgment is consequential. So there's like changes to the behavior of the actor that come as a result of the judgment that we make on how well the actor is making their decisions. So one of the like key pieces of AI accountability and accountability at large, really, across various of the other domains that I mentioned in product safety, like with vehicle safety, food and pharmaceuticals, is this idea of an independent evaluation with the goal of accountability, and we call that an audit. So I'm going to get very like, this might be too nerdy, but for those that are accounting adjacent that might have taken an accounting class, you probably recognize the idea of the 3 lines of defense. So, you know, you have like the people that are involved in the engineering process, in this case, training the model. You have like compliance, security, quality assurance teams. You have senior management, a governing body, probably above all of these things. And the internal audit team is sort of the 3rd line of defense. So outside of compliance and security, you sort of have this independent group that kind of relays the goals of the organization to what's happening across all these other teams. And the external auditor is not within the audit target organization at all. They're on the outside. And they have obligations to a completely different set of group of folks. So they, you know, they're looking at their standards of performance are coming from, you know, the public, proprietary standards, or government regulators, or the courts. Oh, sorry, my animations are not as pretty as I thought. So in terms of who actually, you know, how we actually categorize these roles in like traditional audit ecosystems, you sort of have these first-party auditors within the organization assessing against internal expectations. You have these second-party auditors who are sort of contractors or institutional users. So think about it as like the hospital that's making that procurement decision. And they usually have proprietary requirements. So they have requirements that are specific to them, or that they buy or purchase from a separate entity. And then you have the third party, which are sort of completely independent. And they usually typically operate against a recognized standard. So something that me and so I've been working with Dan Ho at Stanford Law about this for a couple of years now. And something that we initially decided was that because in the AI space, we don't really have a recognized standard, third-party auditors are not typical. So the third-party auditors in the AI space don't work in the same way as the third-party auditors in accounting or in food safety. And so we kind of developed a different taxonomy where we said, we have internal auditors in the AI space, which are just people that have signed an agreement with the audit target. They're working in collaboration with the audit target. They typically have full access to the system. They're looking at things, you know, pre-deployment. They're focused on compliance and quality control. And then you have external auditors who have not signed any agreement with the audit target. They typically are focused on protecting represented groups. They do not have the sort of compliance control objective, and they're typically looking at things post-deployment. So this dichotomy was a little bit more helpful for the AI policy space, which was, let's focus on the contractual agreement part of it. If you sign a contract, you're an internal auditor. If you don't sign a contract, you're external. And note that internal and external auditors can be both public or private organizations. So methodologically, what does this mean? A lot of internal auditing just boils down to documentation. This is the first model card at Google, where I did some internal audit work early in my career. Again, when you're an internal auditor, you are within the organization, you have full visibility into all the decisions being made about the system. And so all you really need to do is sort of capture information, key information about these engineering decisions, and then relay that information to key stakeholders in a way that's accessible. And so model cards was just an attempt to say, let's summarize the key details of the model so that we can show it to legal, so that we can show it to all these different teams, and they can have a good sense of what the model is about. So that's like the simplest version of an internal audit system. There's also kind of like a more complicated version of this. So people are like, oh, documentation, that's so easy. But when you're at a large organization like Google, and also you're really worried about some really complicated risks, if you look at finance or like the medical device industry, internal auditing is actually like it's a team's full-time job. It's a very complex, there's a lot of different types of documents you have to produce. You go across multiple teams across a large organization and get complicated very quickly. And so one of the kind of first projects we did there was develop an internal audit process and adapt these are a lot of documents that exist in other fields. And we said, okay, what does that look like for sort of this AI space? If we're documenting the key details about the model, and we want to sort of mirror the internal audit practice in other fields, what do we need to capture about particularly the AI systems we're worried about? External auditing is a bit trickier. And that's sort of the latter half of my experience with auditing was sort of from the outside. So as a reminder, if you're an external auditor, you haven't signed a contract with the audit organization, you're fully external to that organization. And so there's a lot of risk that you're holding on to. I'll just name a couple. The first risk is this idea of harms discovery, meaning most of the use of AI systems is not visible to those that are impacted by it. If someone makes a hiring decision about you and they don't notify you that an AI system was used to screen your resume, you will never know. Same with like a rental application, a benefits application, whatever. And so there's a lot of these quotes from several, articles and case studies, which is that, this is the first time we know about this happening. It's not likely to be the first time it is happening. And so that's a huge issue, the harms discovery issue. And disclosure issue is like one of the biggest challenges with external AI auditing. It's really hard for you to see from the outside. And the solution policy-wise to that is this idea of AI inventories. So if an organization is making use of AI, they have to disclose the use of the system explicitly. So the Biden AI executive order, for example, required every single department and agency to publish every single AI tool that they were making use of. The sort of second issue with AI auditing externally, so after we did the sort of follow-up work to the gender shade study, the facial recognition evaluation audit, one of the companies that we audited, Kairos, after we audited them, so we used their like application program interface API to like evaluate the model. After we audited them, they immediately raised the sort of bottom tier of the access of their model to like $99 a month, which is like, we're fine, we can pay for that. But then as we click through, it used to be free, but we're like, okay, that's fine. So as we click through, we realized in their terms of service, they had an anti-audit clause in there. And so that happened a lot over the years where after you audit a target and they become aware that they're vulnerable to being audited, they will sort of create these barriers for data access. And so in some cases, the audit target will also come after the auditors legally. So, Facebook is actually quite notorious for this, where they've gone after several groups that have tried to do audit work on their ranking algorithm. And now they're also coming after groups that are trying to audit their open source tools, their open source models. So, just a lot of legal risk associated with doing this work and trying to access data to just do the evaluation. Julia Angwin is a data journalist that has done a lot of kind of on-the-ground investigations of these systems and sort of identifies as an AI auditor. And so she's led a lot of campaigning to sort of support legal action to protect those that are doing this type of studies from legal retaliation from these companies. And a couple of years ago, ACLU actually had a federal court win to allow for an exemption to CFAA, which is like an anti-hacking law that Facebook was using to go after some of these researchers, so that you can now do these studies without a threat of that law being weaponized against you by the audit target. So that sort of protection from legal retaliation is one of the things that we sort of advocate for to make external auditing viable, but it's also one of the risks that you hold when you're auditing from the outside. Another sort of third risk for this AI audit work from the outside is this issue of auditor independence. So there was a consulting group called Orca, and they were auditing an AI hiring tool called HireVue. Orca signed a contract with HireVue to negotiate how they would release the audit results. And what happened is that HireVue took the report from Orca and they put it on their website. And in order to see the report, you had to sign a contract saying that you would not disparage HireVue when you access the report. And so you could sort of see a lot of auditor independence issues where some of those participating in the audits were sort of behind the scenes, working with the audit targets in ways that were not transparent. And then I'll say the last point around external auditing is post-audit measures. So sometimes historically you could do an audit and the auditor would not react. If just because you call out a company doesn't necessarily mean that the company has to respond. And so a lot of people in the external audit space think about different approaches of communication and grassroots advocacy in order to promote ways to not just make sure that they do a high quality evaluation, but that evaluation actually feeds into meaningful processes of accountability. Okay, I'm looking at the time, but I think I'm almost done. But all this to say is that a lot of those external audit issues in particular led to me getting much more into the policy work. So like I said, this is not our first rodeo. We have audit ecosystems for food safety, finance, medical devices, you name it. And in each of these different industries, there's a whole set of laws that legally protect auditors, allow for auditors to have authority in terms of reporting and post-audit actions. And so we have thought a lot about the policy ecosystem around auditing. How do we actually design and advocate for regulation and policies that can enable external auditing? I'll end here, which is pretty much that, a couple of years ago, this is, again, slightly different time from today, AI auditing kind of had like a heyday. Like the Biden administration was very into this idea of third-party auditing and sort of third-party evaluations. And one of the things that we're seeing moving forward is there are still legislative actions being taken to support AI auditing. So not as much at the federal level, but at the state level in California, there's a new bill that was drafted just a couple of weeks ago, introducing the idea of third-party audits for large language models and frontier AI systems. People underestimate the current administration and executive branch, but there are actions being taken by the Trump administration because they are very interested in AI adoption. And procurement is a huge part of adoption. Evaluation is a huge piece of procurement. And sort of third-party evaluation and auditing is a huge element of that. And so they've actually been very proactive about this as well. The other component of executive actions is this idea of voluntary commitment. So getting the companies to agree to adhere to certain practices before they release the model. And that's also been very active as well. And then sort of finally, just to flag something, there are these AI safety institutes. They're all rebranded in various ways, but I work a lot with these groups of folks within government that think about evaluation very specifically. Their mandate is to do research on evaluation for the sake of feeding it into accountability processes. So I think that's been one of the biggest wins we've had in the last couple of years. So yeah, here's like a glimpse of sort of a bunch of things that have happened and are still on the table to happen in the future and make me sort of optimistic about this space. And sort of to end on a more kind of grounded note, I start with those stories because I think sometimes when we work in this field, it's very easy to forget the fact that some of the research that's done and some of the practices that are developed within the machine learning space extrapolate. They come as machine learning models become products and sort of escape the zone of research, they start affecting real people. And one of the things that makes me very passionate about thinking about evaluation and assessment is that, when these systems fail, those real people get hurt. And the more of these people that I meet and interact with, over the years, I've actually interacted with quite a few of them, you realize that it's like, not just anybody, it's like those that are sort of historically marginalized, those that are elderly or minoritized in other ways, that have the least access to recourse, that are the least familiar with the AI field. And so if we do want to have a positive impact as a field, we have to seriously start thinking about what it means for these systems to work and get deployed responsibly. Okay, that's it. Thank you so much.
I know some people may have to leave, maybe we'll try to take one or two questions. Then people who are interested can come up and talk with the student. Yeah. Yeah, go for it.
Any comments on AI alignment challenges?
Yeah, so the UK, for context on what an AI alignment challenge is, the UK has been running these AI alignment challenges, the UK AI Safety Institute. So the AI Safety Institute's role, like I said, is to do AI evaluation research. And they were actually given the most money out of all the AI Safety Institutes. I think they're under Rishi Sunak, they were given like over 100,000 pounds, 100 million pounds, sorry, in terms of financial commitment over several years to execute AI safety work. They're now rebranded to the AI Security Institute. And so one of the ways that they've been using that money is by having these challenges. I actually got a grant from them like this week, where they had a fund for like sort of applied evaluation work. That's kind of the work I do. But they also had this AI alignment challenges of, you know, what does it mean to align AI systems with sort of what our expectations of these models are. So not just evaluate the mismatch between expectations and reality, but also align the model's performance to what we expect it to do. And so that's, yeah, like I think it's good work. I think one of my challenges with that is that like the alignment work I've been exposed to has been limited to just like the model view. And I think if you take a socio-technical view of AI, there's a lot of other factors that make these models fail. And so if you want to align these models to our expectations, it'll probably involve modifications to the model, but it'll probably also involve kind of modifications to processes and details outside of the model as well. So I'm eager to see sort of like socio-technical alignment work, if that exists. Yeah. Oh, there's a question up there. Oh, Jen, I think there's a question there.
Oh, what's that?
There was a question there, but